Yeah.
So, welcome to another episode of Beta Talk. This season is being sponsored by Primary Pro. Primary Pro was set up by my very good friend Dave Smith. Lovely gentleman. Dave's been in the game way longer than me, by a few years. He's always very interested in learning and helping other people learn, and he invented and developed an outside pipe insulation system, specifically actually for people getting involved with heat pumps. So that's called Primary Pro. Check it out on the website. So today I'm joined by Ken Bone. Regular listeners would know who Ken Bone is because he's the first ever heat pump engineer I had on this podcast. Way, way, way back, whenever that was,
Well,
Ken.
that was a long time ago.
Yeah, and time has obviously done funny things because this whole thing of COVID a few years back distorted time a little bit. What it did for me, I sometimes forget what year I'm in. Well, we're back to the show, Ken. So today we're just going to have a little bit of a bird's eye view of what Ken's, as this whole industry is starting to progress, to grow, the heat pump sort of domestic UK industry. Ken, one of my favourite engineers. I mean, funny enough, I was just at an Octopus event the other day. Yesterday, I come home, had a good chat, well, a chance to chat briefly with Greg Jackson. And a few months ago, mate, well, maybe that's a year ago now, I was chatting to some people at Octopus, and I think Greg's got a friend who's in the House of Lords who has a heat pump system and needed some people to, or needed someone to have a good look at it. And Ken's the person I got to go and have a look at that. So Ken's been around heat pumps a long, long time. Ken, welcome back to the show. So, what are we seeing out there in the big wide world of heat pumps?
Well, yeah, thanks for having me on. It's been a while. As you quite rightly said, I'm no way expert. I'm no way knowing everything about heat pumps. I've just been around them a long time from the very early beginnings back, 20, 25 years ago, when they were noisy, they were not very efficient. The systems that they were being bolted onto or pushed by certain manufacturers also made them less efficient. So I'm still in my time at Ultimate. I still go around and try and do some consultancy work for those older heat pump owners and try and improve them, like making them go to open loop and getting rid of a load of the junk. So let's just talk about controls and junk then, shall we? Let's get off to
Before we do that, Ken, we should just mention that where Ken is working was my previous sponsor. So a big up to them, Ultimate Renewables, because they used to sponsor this podcast or one of the seasons. So I'm very, very grateful to them for doing that.
thank you. So yeah, controls. So it's at the moment where I work at Ultimate, I'm the training technical manager for URS Ultimate Renewable Services. So we try and promote the open loop philosophy as much as we possibly can. We definitely don't say no to buffers and certain situations and project specifics, but we are finding that there is a lot of misinformation still out there in the field, both for the homeowners and for the engineers and for underfloor heating companies and things like that. So I typically will go to a job and the installers done his underfloor heating and everything else, and he's got a few extra pumps on there, and I'm like, why have you got these bits and pieces on there? And it's like, that's how it's always been. That's how we used to do it, and that's how I've done it for the last 10 years. And I'm like, okay, but and then I try and go down and help them learn, or maybe give them a different view, and maybe pull a couple of plugs out of the circulators that they don't actually need. And lo and behold, most of the time the system works without those extra circulators. But from a client's point of view, they still want micro zoning control. Um, and even though we try and do the weather compensation, and forgot that hopefully we'll touch onto how I think about heat pump controls later. Um, they want that microzoning control because again, that's how their previous gas boiler system or whatever they had was. This is how I ran my system. I done a training session a couple of weeks ago, and there was only out of 7 guys, there was only one guy that knew about weather compensation, um, and he'd already done a few heat pumps anyway. But the rest of them were boiler guys, and I was saying, like, do you know anything? Have you ever fitted a boiler with weather compensation? And the answer was no. So where do we go with that? I mean, my views on weather compensation and how much gas it can save throughout, the 27 million gas boilers in the UK. And even from a CO2 point of view, every gas boiler produces about 2 tons of CO2 every year. And I'm not even talking about industrial processes or oil systems. I'm just talking about gas users. So why haven't the industry, here comes the rants, why haven't the industry pushed that technology? Let's take Wiesmann, for example. I started off doing weather compensation, low temperature gas systems 20 years ago. I started going down that wormhole, which eventually got me into heat pumps. I had a falling out with Valent. Won't go into the details, but let's say we had a falling out, and I went over to Wiesmann, and I never looked back. And since in my boiler days, every Wiesmann I fitted had weather compensation installed.
Just to pick up on that, Ken, what made you, as an engineer way back, back then, 20 years ago, what made you come or think about weather compensation or come across it? What specifically made you, as a plumber, heating engineer, become aware of it?
I wanted to try and get the best out of the system possible. And yeah, I've always been that way. Of like, how can I make this system efficient? And sorry, something quite loud is going to pass my house. I don't know if you can hear that. Oh, it's a lorry. So yeah, I was trying to make every system I fitted as efficient as possible, and I was going to get the book. You remember the book, the Permo book that I had with the low temperature.
Thermo, yeah.
Yeah. So, and then I came across things like that and started looking into low temperature systems as a whole, um, predominantly with gas, and then as you dig deeper into the wormholes, this thing called heat pumps came up, and I was like, okay, that's quite interesting. And then the more I learned about heat pumps, then the penny dropped, and I was like, this has got to be the future. Gas is a finite resource, oil's a finite resource. Why aren't we making every gas boiler with out the box with weather compensation? And the answers I get is it's a pain to set up. It's a pain to get right. And it's even more so for heat pumps. You know, we a heat any start of a heating process, a heating system process is good heat loss. We all know that. You have to get a good heat loss. And that heat loss is based on your design outside temperature. So I need 10 kilowatts when it's -2 outside, and I need a flow temperature of 45 degrees. But the problems, that's okay. That's for the worst condition. That's what you're designing the system for, the pipe work, the radiators. We need to get that 10 kilowatts down a pipe to some radiators. And that's why pipe sizing is important. But the rest of the time of the year, that heat pump isn't running at 10 kilowatts. The flow rate isn't running at its full velocity. And so the problems lie with weather compensation. Although I love it to bits, the problems lie for the end user and for the installer is getting it right for those changeover months. So what we find is now the weather's getting glorious now, but up until recently, customers were phoning us up and saying, I'm too hot in the house. So that then goes on to someone needs to either speak to them on the phone. So sometimes I do video calls with the client. Some clients do get it and they understand that they need to tweak it and mess around with it until they find their correct comfort level, their cruise control of the house, or whatever you want to call it. Engineers are the same. They don't understand that they need to tune the system. So I was thinking about it and going back to my rant on LinkedIn recently. I think heat pumps controls need an upgrade, an update, and they all use the same technology. So heat pumps as a whole, it's the same technology. It's what it's bolted onto that makes the difference. But they all use the same weather compensation parameters. I'm going to do 45 at -2, and I'm going to do 30 degrees at 10 degrees outside. And so I was thinking, why can't we just have a heat pump controller that has room influence? So anybody that doesn't know what room influence is, or my version of room influence is, I set that house to 21 degrees, and the heat pump comes on and ramps up until the house is getting close to 21 degrees, and then backs off automatically. So if you had that type of setup, all you would need to do is put in your DOT calculation. I need my 45 degree at -2, and then the heat pump works it out. It already knows what the outside temperature is. You shouldn't need to tell it what the outside temperature is. It already knows this. It knows what the internal temperature is. And obviously there's a delta T between them two. And the heat pump will automatically ramp up and should be running optimally until it gets that house up to temperature, and then just start backing itself off automatically. And that will mitigate end users' problems, can't understand the heat pump, don't know how it works, installers not understanding and how it works, and then or those that do, having to keep going back and keep fine-tuning Mr. Miggins' heat pump. One day they're too cold, one day they're too hot, and okay, just play around with these figures, these parameters for a few days and see how you get on. And I think that would eliminate a lot of the problems.
Do any of the heat pump manufacturers provide room influence with their weather controls?
I think Valent do, Viessmann do. I believe the new Kenza, not the new Kenza, the new Grant heat pump, the new R290. I think that now does. So that technology is evolving, but
are they add-on packages? I mean, is it something that so with some heat pump manufacturers, you kind of, when you buy the heat pump, you can buy the extra ancillary pieces and et cetera, et cetera. So do these come as standard, or are they something you have to ask for?
I think Valent come as standard, Viessmann come as standard, and I believe the Grant one comes as standard. There might be others out there as well that do this, but let's look at where the badged industry is going at the moment. So we've got people like Clavette, Media, Riello, Bosch, Baxi, and there's quite a few others now, and they are all using the same branded heat pump. Mm. Let's be honest about it. They're using all the same branded heat pump, and that's great. That means heat pumps are becoming more mainstream in the industry as a whole. But the controller is exactly the same for all of them. So let's pick one controller. If you put it into a room stat mode, I mean, it's still working as weather compensation, but if you put it into a room stat mode, that room stat mode is on an on-off switch.
Right.
It it's, if your weather curve settings are still too high, the house will get up to temperature and then it just completely shuts down the heat pump, and then half an hour later it comes back on. So that's unfortunate. I think,
It's
there's
working like a heating system on off
yeah, yeah.
thermostat.
So we're back to the on-off controls, and yeah. So this is the problem. I set it at 21 degrees. It gets to 21 degrees, and it completely shuts down the heat pump instead of modulating the heat pump down. Um, so obviously, people have grabbed onto this. It's not the only. I'm not the only person that's seeing it. It's people like Haven Wise, Homely, Passive. They've seen this gap in the market, and they're trying to bridge the two together to make it better for the end user. And fair play to them. I mean, we you know if there wasn't that gap in the market, those companies wouldn't be around. So they're trying to create that room influence. And going back to your previous point, that then is a bolt on. You have to buy a heat pump, and then you have to buy an additional piece of kit to make your heat pump even more efficient and work, in my opinion, better than it does come out of the box.
But arguably, what we're saying is, so obviously things like Havenwise is an app or API connecting to your heat
Yes,
pump.
it is an API.
Homely is an actual physical device that's
Yes.
installed. But are we saying that we actually probably don't really need these things if the manufacturers up their game with their own individual controls?
Yes, I would say that.
Because I suppose the one of the USPs of some of them companies we've mentioned is they're checking also electricity pricing. But I suppose, I mean, could a manufacturer's onboard controls do that as well? Maybe.
Yeah, I mean, okay. So take a basic heat pump controller. You could set up your own schedule around that cheap price. So you could say, okay, I'm on Octopus Go here at home. It's 7p between 11:30 and 5:30 a.m. Okay, so I could say I'm going to do a bit of preloading, say from about 3 a.m. I'm going to set the temperature for my heating system a little bit higher, my flow temperature a little bit higher, take a hit in efficiency, but the actual running cost will be cheaper per day. And then when it comes to the dearer time, my house is already pre-warmed, and then what I can do is, or what someone could do is back that heat pump off right down, because it's already done a lot of preloading. And you're right, Haven Wise. I've got Haven Wise at home at the moment. I'm playing around with it, and that has been doing that for me. It has. I can clearly see that in the middle of the night, it will bring my heat pump on, and my heat pump will run quite hard to start loading up my house for the morning. And then when the morning comes, it either backs off right down, or it turns off until the middle of the day again, or something like that. So that is hard to get across to a client as well. When I do a commissioning now or a handover, I'm always trying to see if they've got an EV. So if they've got an EV, chances are they might have a cheap tariff. And then, let's do your hot water loading at night time. Let's do some preloading in the morning. But those those controls are limited. The actual heat pump controls are limited. There's no AI in them, like a Haven Wise or a Homely, that's constantly looking at the weather, looking at your time of use, tariffs, and they will run your heat pump to the best they can, or the cheapest. So the idea is they will try and run it better, but also cheaper. And sometimes cheaper means you actually take a hit on efficiency. So Scott, I'm not a big Scott chaser. Okay, so let's go on. So I'll give you an example. So some person, Mr. and Mrs. Miggins, they have uh, a winter window of operation. Let's call it 10 months. And that is where your SCOP is based on, is those 10 months of them running their heating systems. But if Mr. Smith down the road is a bit frugal and he only runs this for 7 months, his SCOP window is smaller and his SCOP number would also be lower because he's most probably turning it off and on in those colder, chillier periods where the system's not running quite as hard or running harder than Mr. and Mrs. Miggins down the road. So I'm all about trying to make the system, yes, it must be efficient, but we can also now start playing with the time of use stuff as well. Um, I mean, another example is my peak PV time is about 2 p.m. So let me do a hot water cycle at 2 p.m. because the temperature's up and I'm getting PV. But I have to flip that in my own property. I've got a system and a setup that I run in the winter. And then as the weather starts to change, at one point it completely flips over. And then I start doing everything during the day. So in the winter, I do everything at night because the rates are cheap. And in the summer, I do everything in the day because the sun's out and I'm starting to get some PV and my heat pump's not working that hard anyway. So that automation for me is not as clear cut yet. Um, but yeah, again, this is a lot of this stuff now is software. It is the heat. We know the heat pumps work. How can we get the heat pump with the end user's time of use tariff, with the PV package that they have and everything else? How can we get that giving you that heat pump to give you heating and hot water at the cheapest per day cost?
How do we do that? I mean, I just want to mention something. So obviously, I mean, you love monitoring your heat pump systems. You know, you've tested different manufacturers' heat pumps. You've tested different systems like Homey and Havenwise, all sorts. You love doing that, Ken. And so do some of the innovators that have had heat pump systems put in. People like your Tristans who run open engine. But the majority of people, when they start to get these systems, are not want to going to go anywhere near the controls. Don't want to know anything about the controls. All they want to know is that they're warm, and that's why that thermostat on the wall has always been sort of kind of. And you said earlier, didn't you, that people do like Michael? They like they like to feel in control. That's a psychological
Yeah,
need of humans.
yeah.
So that this notion that they are in control of certain rooms' temperature, you know, they might have some visitors coming, uh, and so they know that particular side of the house is going to be at 21 or whatever they said. So they think they've got control. I mean, they turn that dial up to a particular number that they think. I mean that as we know, wall thermostats aren't that great at measuring actual temperature. So it might
They're
say
very inaccurate, a
it
lot
might
of
say
them.
21 on the dial. I mean, you get people say, yeah, you know, 21's not hot enough for me, and I always want to be at 22. Well, you're not actually measuring your temperature anyway. So you might have a system, a really good heating system, you know, with weather compensation, and actually your body is quite happy at 19 degrees. You don't
Mm.
know because that wall thermostat is just an on-off switch, really. It's giving you an indication of roughly where the temperature is at. But people like to be in control, so they do like the idea of that. You know, if they feel cold, they can turn it up. If they feel too hot, they can turn it down. Now, what we want, obviously, though, is a heating system that's doing everything in the background for these people. They haven't got to think about it at all. And that's possible, isn't it? You know, if you can get people to put systems in that are going to just automatically run. Um, I think you like this term, don't you? Dialed in, the weather compensation's dialed in properly, or people have tweaked it to where it's going to work optimally during the winter. But to work with obviously the tariffs. So are we saying people will always have to have these sort of add-ons, these bolt-ons, whether you know, what these companies now that are sort of you know, like your Havenwises, your Homeleys, your Passive UKs, there's quite a few of them now, isn't it? Because like you said, they've seen a gap in the market. But I mean, it's not that hard for the software engineers working on heat pumps to actually do this themselves, I would have thought.
No, well, this is my argument. This, it is just software. I mean, even back into my Daikin days, which their heat pumps had smart grid control. Every heat pump has smart grid control, but no one really uses it yet. So, the smart grid, it will come. Basically, when the grid's at a low CO2 or it's at a cheaper rate, a signal could be sent to a heat pump. I mean, I do this. I played around with this with my own systems and with my own automations because, as you know, my system is a Frankenstein system anyway. So that heat pump could either ramp up or ramp down depending on the circumstances of the grid. So we're trying to get the grid. So yeah, I mean, I could talk about it for hours, mate. But we're trying to get the grid leveled out, aren't we? I mean, that's the whole idea. We have this peak and trough of the grid every day, and pretty much the national grid. I've spoken to senior people at the national grid. They know what's coming every day. There's a peak and trough, peak and trough. So the trough, the trough is at night time. So hence why the tariffs are cheaper at night time because they want you to charge your car, they want you to charge your battery, you put your washing machine on, your tumble dryer, everything else. Do it at night time. And if that was rolled out across millions of people, that would take or lessen the demand during the day. So the peak is obviously during the day. So but heat pump systems do have smart grid capabilities built in. So why can't they have a signal that's sent to them by the national grid? Say, right, I want you to preload Mr. and Mrs. Miggins' house, or in combination with like Haven Wise and Homely and stuff like that. I want you to preload every house in the country at 4 a.m. because we've got a mass surplus of energy on the grid, or do a hot water cycle or something like that. I mean, the more you think about it, the more you think, why aren't they doing this? Why isn't this link of a chain joining this link of a chain? And yeah, okay, I'm a nerd. I as you say, I love the data, and I'm always trying to think of ways of bringing these links together for people. But the and short, long and short of it is, you're right, exactly what you said 5 minutes ago. Mr. and Mrs. Miggins, all they want to do is turn a stat up and down on a wall. They're not me. Then they don't want to be like me. They want hot water and they want heating and they want it efficient and they want it at the cheapest rate. So why can't all these entities bring it together and say, right, this heat pump, you plug it into the internet, you tell it what the tariff you're on, you set the temperature of the house at 21 degrees. Mr. and Mrs. Miggins can turn it up, turn it down, whatever they want to do, and then the rest is automatically done and works with the intelligence of the heat pump controller, linked to the internet, linked to the weather, linked to the time of use tariff. And that's what these third party controls do. These bolt-ons. So
Optimizers, not
yeah,
control.
oh
I
yeah,
like.
it's an optimizer.
I call
Yeah,
them optimizers just because otherwise people get confused that they think they are third party thermostat, which, as you and
yeah,
I, we're quite
yeah,
against for obvious reasons.
yeah. I mean, I can give you a couple of examples. Recently, I went to two houses within the same week. One was an old Samsung microzoned on-off controls. Guy, the family were complaining that the bills were quite high, and it was good. It was a smallish property, a 3 bed, 4 bed, and I disabled the on and off control. I don't think it was actually. It might have been in weather comp, but I certainly disabled the on and off control. I pulled a load of heads off the underfloor manifold, disconnected the pump on the manifold, set it up. 2 days later, he rang up. He said, or about a week later, he rang up. He said, "Do you know what?" He said, "My house is now warmer than it's ever been, and it's costing me less to run." And I done the same for a very large property near me with a ground source. It was actually a Kenza ground source. Um, Brand new property or newish property, 2.5 years old, and the customer said, "This house has never got warm. I can't get it warm enough." It had a buffer, and again, the Kenza was being controlled with on and off control. The weather compensation hadn't even been turned on, and I done my first visit. I pulled off every actuator in on every manifold, and I let the heat pump burn. And again, she was quite intelligent. Actually, she was quite practical and quite intelligent. This particular lady, and within about 4 days, she rang me up. She goes, "The house is 22 degrees. I need to turn it down." I'm like, "Okay, so that's fine." So I said, "Well, you need to make some before you then start going back and putting on actuators on certain rooms." I said, "Don't do that yet. Let's try and get the weather curve dialed in a little bit more. And then if you do then have a room or a couple of rooms that are still overheating, put the actuators back on the manifold." And I haven't heard from her since. So I'm guessing it's all hunky dory. And
I'm just going to
actually
explain.
need to give her a bill. To be fair, Ultimate needs to give her a bill.
I'm just going to explain just for the layperson, Ken, what actuators are. So if you imagine a manifold basically is where all your heating loops sort of meet up, join up, and then they're going off to their individual rooms. And an actuator basically is an electronically controlled valve that's shutting that loop on and off. So you're
Yeah,
either getting
that's
flow
it.
around it or you're not getting flow around it. And these actuators tend to be controlled by their own, well, a lot of times their own thermostats.
Yes.
And what Ken's just said here, he takes them off and that's what they call open loop. I mean, we're getting a bit of pushback, Ken, from. I mean, I do know I mean, so like Heat Miser. Some people will be aware of Heat Miser. They're a controls manufacturer that specifically went down the underfloor heating route
Yeah.
way back in the day, didn't they? And
Yeah.
of course, you've now got engineers like yourself and lots of other people discussing open loop and saying that we don't need all these individual thermostats in individual rooms. Yes, they might look all fancy and Blake Seven and Star Wars that you got this lovely digital thing in every single room. People think, oh, that's good. But what we're saying is doesn't really do much or doesn't benefit the system. Now, obviously, third-party controls like heat miners will want to argue against that because that's their market. They will want, and I know these third party controls are realizing we're moving and shifting to heat pump market, so they're trying to encroach that. They're trying to make people think that we need all these controls for heat pumps as well, and of course, and some of them have loud voices. Their associations have loud voices. So,
Yes. This is the
as
problem.
as people will know, I'm quite critical of the HHIC and BEMA. So BEMA stands for, well, I can't even remember what it stands for, but they have within BEMA, they have the controls manufacturers kind of association. And at the moment, if you look at social media, because we all sort of live on social media, well, not all of us, you've got these associations like HHIC and BEMA constantly putting out posts to make themselves look good. Whereas I could argue, well, what have you been doing for the last 2 decades? So, for instance, HHIC were up at Westminster on April the 1st, April Fool's Day, ironically, because that's when April Fool's Day 2005 is when we mandated condensing boilers, which, as Ken has already said at the beginning, that's when he started to use weather compensation on boilers. That's what because he realised that's what you're supposed to kind of do with a condensing boiler.
Yeah. Yeah. Yeah.
The HHIC, arguably, and they can argue with me, they're welcome to come on my show and argue with me, and they can debate all day with me all day long. But they never promoted that technology because within their HHIC are the large manufacturers of third-party controls like your Honeywells, etc., etc., who just want to sell you stuff. They would
Yeah,
like to sell you stuff that's in every single room because that's yeah, that's a big market for them. Oh,
yeah, yeah.
let's
This
convince
is the
people they
problem.
need thermostats in every single room. And this is the trouble. This is what engineers have been up against. You know, good engineers that sort of have took ownership of their own learning, like Ken did back a couple of decades ago. But of course, back 2 decades ago, Ken, you and I didn't have social media to sort of talk about this
No,
stuff on.
no,
Now
no.
we
I
do.
thought about that.
And, you know, I don't like upsetting people personally. That's not what I'm about. I'm quite a humble guy. But I will call out associations if they're not doing good work. They don't like me doing it, but they
Mm,
are not and haven't done great work. They've just been primary concerns about sales for their members. So the HHIC, as far as I'm concerned, hasn't done much good for this industry, nor has BEMA, as much as they like to sort of make out they have. They've actually confused engineers, they've
yeah,
confused the public, and of course, we've got great engineers out there. The UK's always had great engineers. We're famous for it. And of course,
yeah.
thankfully, you guys have got a bit of a voice now.
I mean, yeah. I mean, just look at our good friends Damon Blackmore, Craig Brooks, Liam Barry, John Woods. They didn't go to work saying I want to be famous. They went to work and they wanted to do like what I was doing 20 years ago. They were trying to, how can we make this system better? How can I improve my pipe work? How can I improve my lagging? Um, and through, as you say, the social media, they've become famous and influencers because they are doing, how can I put it? Um,
Conscientious,
they
competent work.
are slightly pushing against what the manufacturers and the control industry want you to install. So uh, so I was trying to think of a point. So yeah, back to my early days, 20 years ago, I was not following Part L in controls. I was, I still get people say to me, mate, I need to fit a zone valve for the upstairs circuit. Okay, but you've got radiators upstairs. Yeah, yeah, I've got radiators. And you've got TRVs on those radiators. Yeah, yeah, I've got TRVs in the bedrooms. A TRV is a zone control. You don't need that extra two port. And so this again, this is I need a two port because I need to turn the upstairs off completely. Well, if your weather compensation is dialed in and your TRVs are dialed in, your upstairs will shut off. You don't need to do anything. You don't need to have a special app just to turn that zone valve off. Um, and so there is two sides to the story. So um, smaller properties, let's take your average property. I think zone control almost could be eliminated, apart from a bit of bedroom control and maybe a few areas. So we try and promote at least 40 or 50% of that overall circuit is open to the heat pump. So we've got our volume covered, we've got our minimum flow rate covered that heat pump needs within the system that we've designed or we try and promote. When you start getting to larger properties, controls do come back into play. And because we have just so many areas that some could be overheating on this side if they're on the south side of the building, the ones on the north side of the building, they're going to be cold. So again, you could say the underfloor loops and the radiators on the north side, why put controls on them? They're always going to be cold. They're always going to be calling for heat. So you can look at it in so many ways. Solar gain. People say, "Oh, I need control for the solar gain," and yes, that is true. You do, but we're underfloor by if it was a really cold night and a really cold morning, that underfloor has been heated up, and now the sun comes out like today. The sun's come out and it's blaring through the window, and that room will increase. So back to the intelligence control bit, if the wearer knows that particular the following day is going to be really nice and sunny. Why doesn't it stop the heat in going into that zone in the first place, or that area in the first place? I mean, the list can go on. I mean, how complicated do you want it to be? We just for now, I just want heat pump controllers to be a little bit AI, a little bit intelligent, and for the end user to just go, I want it a bit warmer today, and that's that. We're not even at that point yet in the heat pump world. It hasn't been like that for decades. We've been running around with weather compensation. Oh, change this parameter, change that parameter. Some controllers don't even have an offset control. So an offset is you set a weather curve pattern, and on the controller you can actually shift that. If you want to call it a line, an imaginary line of modulation, you can actually shift that line back and forth a little bit. So if they are running a bit too warm, and they can just shift the whole curve down or the whole line down by a couple of degrees. Some heat pump controllers don't even have an offset control. So again, the end user has no trimming, no way to play and get that comfort level that they want. So they've got no way of doing it without bringing up an engineer.
Hmm. I mean, obviously, some consumers will like to sort of dive into the controls and work out how they work. But ideally, most people in society are going to want to, if they are going to need to do that, do it very, very simply, like they're used to with a dial. You know, they turn it down
Yeah,
1 degree, turn it up 1 degree. I mean, controls are going to play a massive part, aren't they, in this industry? Because obviously we've got things like home energy management systems. You've discussed this whole thing around flexibility of the grid, which is something I should learn more about. I mean, I'm chatting to some people in Ireland at the moment about that, and things like, fast frequency response. I mean, one of the questions they were asking is how quickly can a heat pump shut off? Can it be, because fast frequency response, I think, requires something to be shut off with something like 0.05 seconds. Now, like I say, that's not my my expertise is not around grid and all this kind of stuff. But I'm going to try and learn as much as possible, because this whole thing of being able to shut things down quickly,
yeah,
for
yeah.
the grid to be able to supply different services. I mean, are heat pumps able to sort of shut down that quick? I don't really know. I'm going to have to ask these people what they actually are sort of
Yeah.
trying to achieve, because it's not my area of expertise. But it's obviously something that's very, very, very important. This whole demand side
Yeah.
response of the grid. You and I know people that are quite high up in that world, and it's something I should really start to learn about, because it's definitely not my bag at the moment.
The heat pumps are not so if we gave it a smart grid signal to ramp down, the heat pumps won't do that immediately. So let's say a heat pump's it's midwinter, the heat pump's running at 80% of its capacity, and all of a sudden it gets sent a signal, and it might drop 15 off. It might go down to 65 capacity, or 65% of its capacity. Now that would take potentially a couple of minutes. The point is you've got, if you have millions of those on the grid in households that all got sent that signal instantly, that's where you create more capacity on the grid that the grid wants and needs. And it's the same for batteries. So your 10 kilowatt battery, or whatever. I mean, I'm nearly up to about 60 kilowatts now. But I could, again, that battery could have a grid signal sent to it to upload to the grid. On an instant, I want you to upload your, I don't know, let's say it's 3 kilowatts from your battery. I want you to upload it to the grid. Now, again, if we have millions of those on the grid, and again in homes that all got sent that signal, that would give the grid a lot of extra capacity when they need it. It might only be for a few minutes, and then once those few minutes are done, or something's on the grid, the spike has gone from the grid, the signal gets taken away, and then your heat pump and your battery of those millions of houses will go back to normal. And that's where we're getting to. That is going to be the future. They're already doing it with car chargers. So my car charger is linked in to the Octopus Go tariff, and it just doesn't switch on and run flat at 7 kilowatts. Charge the car, charge the car, charge the car. It will vary throughout the night. It will vary. It'll go up and down a little bit. It might be 3 kilowatts charging, and it might be 5 kilowatts charging, and it might be 7 kilowatts charging, and then it will back off again. And that's being influenced by Octopus themselves. I still wake up with a fully charged car, but it's not an electric shower. I've switched it on. It's going to run at 7 kilowatts and 9 kilowatts for the next 20 minutes, full stop. Going back to grid capacity, I know I'm waffling on now. Going back to grid capacity, a lot of talk is around the heat pumps are going to damage the grid or melt the grid and stuff. And so the grid actually knows. So the whole national grid are fully aware of what's coming in the future. They have the capacity and capabilities to run those heat pumps. The problem is that is little bits of the network that are bottlenecked. So if you had a village and all of a sudden overnight they all had heat pumps, that could potentially be a problem. And that's where you get the things of, my heat pump's going to melt the house or melt the grid. The average house is about 7-9 kilowatts. The input to that 7 or 9 kilowatts might only be 1.5 to 2 kilowatts. So, I know I've ranted on before about, the 7 kilowatt, 9 kilowatt showers. You don't necessarily need D&O permission to install those, but they have a panic attack when it comes to heat pumps. And the reason why they have a panic attack is those 20 years ago, heat pumps weren't inverter driven. A lot of them weren't inverter driven. A lot of the ground source weren't inverter driven. So they came on with a massive clunk, and their ampage pull from the grid was 50, 60 amps very, very quickly. Now, for anybody out there, your typical house, you have 100 amps maximum load that your property could use. And that's where they initially, I think they got really scared, is because this heat pump would come on and pull 60 amps only for a split second, then it would go down to about 18 or something. But again, let's say they have millions of those all switching on at the same time. That would then potentially damage that part of the network on the grid. But now everything's inverter. So, the heat pump comes on, it starts at a 500 watts input, then it might go up to a kilowatt input. We're looking at about 3-4 amps max.
That's an interesting point. Okay. Ken, you made an interesting point. So obviously people do sort of say about this, why do we have D&O permission for heat pumps when there's lots of other electronic technology that we install into homes? Like you say, your showers can be up to 12.5 kilowatts, some of them electric showers, can't they? But there's no D&O permit. But yeah, back in the day, you're right, you had your capacitors, didn't you? Poof, that heat pump fired up. And obviously, well, all heat pumps really now. Well, I mean, Kenzas don't. Some ground source heat pumps don't have. Inverter technology, I think it was 1981 Toshiba invented inverter technology. So it's been around a long, long time. It obviously took a little bit of time for every manufacturer to sort of take it on board. Same year, the condensing boiler came to the European market, and yet the HHIC still didn't promote weather even as far back as 2005, and I don't know what they did, if I'm honest.
my first condensing boiler was the Podston Envoy. I was an apprentice when the profile came out.
And that's when you've been able to push heat in at the right, because I have mentioned this on the podcast before, but if you're a new listener and you might be thinking, well, yeah, why did heating controls come about? Well, they came about, there's some laws of thermodynamics, and the great thing about our industry is you can't argue against them. I mean, some people try to, but you can't argue. Now, let's take the food industry or the pharmaceutical industry. One. I mean, Ken and I are quite old, so one week eggs might be bad for you, the next week they're got good for you, and you'll get different research that
Yeah.
suggests both of them case points. But 1 + 1 is 2, and in the heating industry, we've got laws of physics we work to. Now, controls came around in our industry because your boilers, when we went to switch to central heating systems, because homes had heating, you had your electric bar fire in your lounge, or your gas fire in your lounge, or paraffin heaters that you would carry around. But
Bar
you,
fire. Crikey, remember those?
yeah, used to smell, didn't they?
Used
But
to have them in the bathrooms.
yeah, they did, didn't they? But central heating, which has been around, in the commercial world for a long time, mid 1800s. But when central heating started to become popular in homes, um, because we used hydrocarbon fuel, hydro being the operative word, it's got water in it. So whether it's oil, coal, anthracite, which is coal, gas, you've got water vapor in that flame. And if that water vapor hit a metal surface that was at a certain temperature, dew point, which changes, it's variable dew point, but it's around about 53 degrees, 56 degrees, your water vapor would condense out. And if it condensed out onto the metal that the flame is heating, you could rot that metal,
Yeah.
which it did. And you're trying to protect a boiler because boilers were quite expensive back in the day. So you ran your boiler temperature high to prevent that from happening. Now, what that meant was the flow temp to your radiators was always very high, so it's pushing heat into the home far, far too quickly, far, far too quickly, which is why you had the controls industry come around, because that can then say to the boiler, switch off now because we're overheating the home. And that's what your wall thermostat did. That's what your TRVs did. It was always switching the heat source off because we're always pushing heat into the home too quick. I always
Mm.
tell people to think of heat as something that moves at speed, and it moves at different speeds. Okay, heat and temperature are two different things. And but when we invented the condensing boiler, it didn't matter what temperature we now had in the boiler. So it didn't matter because we could the condensate that was forming, we could take that safely away.
Yeah, get the latent heat out of it and stuff.
Yeah, so that's one so you get the latent heat. So that's why it was more efficient as a boiler, but as
Mm.
a heating system, it meant we could push heat into the home at the required speed. So if your home needs your 10 kilowatts when it's -3 outside, it's only going to need 5 kilowatts when it's 9 degrees outside. It's only
Mm.
going to need 2.5 kilowatts when it's 15 degrees outside. And we can push that heat into the home at the correct speed by changing the temperatures in the rads. And that's what the condensing boiler enabled us to do. And yet our industry, the UK industry, which became the biggest gas boiler industry in the world till 2016, wasn't really bothered about that. All they were bothered about was selling boilers. And then they try and tell us that we all need control still and stuff like this. And you've got good engineers who've worked out the maths, who know the science of heat, who are saying, well, actually, no, we don't.
I mean, what one of the analogies I use in my training sessions is, for as you rightly just said, and I was going to touch on that as well. So for the last 20 years, we've had our foot very hard on the accelerator, and then we got our foot on the brakes at the same time with controls. Um, so with weather compensation, regardless of it being gas or oil or heat pumps, the idea is you take your foot off the controls, but you also take your foot off the accelerator. So you're trying to do 50 miles an hour down the motorway, but you've got your foot to the floor and the car's actually wanting to do 70, but you've got your foot on the brakes to keep it at 50. Why don't we just take everything off? And so that car boiler is running where you want it to be. But what's generally happened is we've done that with the gas industry for years. We've done this foot hard on the accelerator and foot on the brakes with controls. The industry have literally now just bolted on a heat pump and they're treating the technology exactly the same. The industry is treating the technology exactly the same. So now we have heat pumps with their foot quite hard on the accelerator. And again, people were still trying to adapt the brakes with third party controls. So I've got a little slide in my I've got a couple of slides. One shows a house in two different locations. So the house is exactly the same house. It's the same makeup. One picture shows it on a hill in Scotland with a load of prevailing winds and rain and everything else. And the other picture shows it in an urban environment. And I get the guys to say, so what's the difference? What just by looking at that picture, what can you tell me is the difference in them two houses? And the correct answer is they have two different heat losses. It's the same house, but because of the environment the house on the hillside is located, that will have a higher heat loss, a higher heat demand than the one in the urban environment. So, again, that then will change your heat pump size, your pipework size, and your radiator sizes. It's the same house, you've just got it in two different locations. So the other one I've got is a scale. So what we're trying to get to, I've got a picture of a scale, and on one side is a heat pump, on one side is the house, and in the middle it says 20 degrees. We're trying to balance and equal the heat going into that property that matches the heat going out of that property. If that is correct, that house is always at 20 degrees. So if one gets out of kilter, then obviously the house is going to either get over in temperature, it's going to overheat, or it's going to get colder. So that's the game that we're trying to play with controls. But as you say, a lot of engineers, they've been doing zoning for such a long time that that's just what they want to do. And some manufacturers will still promote and push that, because at the end of the day, it does lessen callbacks to a homeowner. And, a lot of engineers, like the ones I previously mentioned, they will take the time in tuning that system to within it, a hair's breadth of getting that system right for that client. But you could have two houses exactly the same. One person next door wants it at 19, the other person next door wants it at 22 degrees. So the weather curve settings are going to be different for those two applications. It's the same kit, it's the same install, it's the same house, but the weather compensation parameters are going to be different because the people and the occupiers are different.
To close up with a kind of conclude, or before I do that, I just wanted to mention, the engineers. It's not engineers' fault when it comes to this whole thing of zoning. They've been tricked. I'd argue they've been tricked. So you've got all the manufacturers that make third-party controls have been banging on about for years and years and years how you should. It's in Part L. So Part L approved document is around building reg, and they've been saying, oh, and it's not. There's only three words in Part L. That's the actual legal requirement, and it says use effective control. And Ken
Yeah,
and I could quite easily argue, well, I've got no actuators on it, and I've got no wall thermostats everywhere. That is effective, and we can
yeah,
prove that. We can prove it's actually more efficient. So all these controls manufacturers that say it's in place, no, it's in the guidance that you can meet the requirement by using TRVs and etc. etc. But so many engineers, so many people that build houses, so many people everywhere think TRVs are a legal requirement. No, they're not. It'd be stupid if they was.
mm-hmm.
And but so to conclude, and you sort of talked about this thing of weather compensation, and we've talked about how people don't really want to be out; they just want to be warm, and they don't want to stop fiddling with control. Some people will, but most won't. Autonomous self-commissioning systems. So is it possible for the layperson can understand is to have, someone goes round, sizes up your home, they know what size heat pump you need, you put the heat pump in, and then it automatically dials in your weather curve for you. So the homeowner is going to probably say, well, this is what I like to be at 20 degrees, let's say. And if they do start to feel a bit too hot, they've got something where they can turn it down to, let's say, 19.
Mm.
But have we got systems that can automatically do this with the rim influence and weather outside centres that we'll dial in that weather curve automatically?
Yeah, the homely and Havenwise options. That's exactly what they do. They will they were back to our original conversation of Mr. and Mrs. Miggins wants the house at 21 degrees, and especially with the homely, when you set it up for a unit, it says, "Do you want me to commission the heat pump?" And you press a button on your phone, and it will commission and set up the heat pump. It then goes for a learning stage of maybe 10 days of that. So it will learn how hard I need to make that heat pump work to get the house up to temperature. And over a course of time, it will obviously in the background somewhere on some server, it will have a particular algorithm for your own individual property. So that's yeah, that is the control. So it's for almost from an engineer's point of view, an installer's point of view. If you, I mean, I like both Homely and Haven Wise, but from an engineer's point of view, you basically press a few buttons, and the heat pump controller becomes irrelevant. Homely now takes over full control of that heat pump and the end user's requirement of how they want to manage their heat, their hot water. So, yes, to answer your question, there are systems that will commission the heat pump for you. They work really well. These bolt-on systems, bolt-on options, they work really well for systems that potentially are not installed very well. So you will get quite a significant gain from those. For those like Damon and a few others and myself that will have the time and take the effort to dial down the heat pump itself, then it becomes an end user. It's just an extra end user control, really. So if that person does, if that end user does want that control, or the installer wants to not have the hassle of keep going back every couple of weeks, then certainly look at one of those options.
And
Yes, it is more expensive, but look at one of those options.
you mentioned about if they didn't use that, but you've got a good engineer and they might have to go back a few times just to dial that with. But of course, they can do that remotely as well,
Yeah,
can't they? Because
yeah.
obviously, they haven't actually got to physically go back to the control on the heat pump. They can do it over their phone, etc., can't they?
Yeah, there is one company. I'm sorry to the company. Planet Devices do a monitoring setup bolt-on add-on to a heat pump. It doesn't really give you control like a Homely or a Haven Wise, but what it can do is it allows the installer to access a portal that they can play around with the weather compensations from a laptop.
But they can do that with some makes as well, can't they?
Yeah,
Automatically.
yeah.
So some manufacturers make, and quite a few of them as well. I mean,
Panasonic as well.
yeah, Valent, Vitnebe,
Yeah.
Stiebel. I'll ask you in a minute because obviously you've been around the heat pump market a long, long time. I want to ask you if you've seen any sort of changes amongst the manufacturers, and I'll come to remind me in a minute, King, because my memory's rubbish. Now, we've mentioned before that we've got this OEM market. So, like in this particular country, Medea make units for a lot of people. I've been told it's around about 15 manufacturers
Yeah, yeah,
use
it's
the
massive
Medea.
now.
So all the big boiler, well, Valent though, but you've got Bosch, one of their units. One of their units is a Bosch. It's a premium priced unit, and I actually do hear good things about it. But their other one they sell is the Medea. Ideal sell the Medea, and then their other unit is made by Fujitsu.
Yeah.
You got Baxi use the Medea, Riello use the Medea, Clivet use the Medea. Wouldn't it make sense for Medea, Chinese manufacturer, to actually think, crikey, let's make some really, really, really good controls because everyone seems to be using our heat pump. Let's make some really, really good controls that are easy to commission for the engineer and just easy for the
Mm.
homeowner to use. I mean, that would kind of, and then you wouldn't need bolt-on stuff. I mean, that would kind of make sense to people, I suppose.
Yeah, I mean, going back to my very early points, why is that those 4 points of the weather compensation? Why do we have to play with them in the first place? Why, if you just put every controller have room influence and you park it in the living area of that house, it knows what the inside temperature is, it knows what the outside temperature is, and it will automatically bring the house up to the temperature you require as optimally as possible. You wouldn't need to mess around with loads of parameters and I've got to do this, I've got to turn that on and off, and it's like one controller. As I said, it doesn't have offset adjustment. It has an option for radiator and underfloor and fan coil, and I'm like, well, that is that actually three different algorithms built into the controller, maybe. Most of the other controls out there don't have that. It's like, I'm a heating source, and these are the parameters I want you to heat my home. Yeah, I mean, you're right. It needs to come. It does need to come. I mean, yeah. What was your point about what
Well,
changes have I seen in?
well, the
Or have you,
market. I was going to say, what have you seen? Sort of because you've been around heat pumps for a couple of decades. So obviously, as we've got this massive discourse now talking about heat pumps, have you
hmm.
seen any sort of major changes with some of the manufacturers? Are you seeing some manufacturers do some things different? Are some manufacturers doing things that they perhaps should be doing and they're not doing? I mean,
Yeah,
I could sort of mention a few things. I have to be very careful now because unfortunately I upset some manufacturers and end up having sort of emergency meetings because Nathan Gamble just said something on LinkedIn. But and I don't like upsetting people at all. But sometimes some manufacturers need a little bit of a nudge, I suppose, in the
yeah,
right direction. I mean, Grant's interesting. So obviously, as we know, Grant were making a unit. You've tested some Grants that were
yeah,
Japanese
yeah,
Shofu used to make theirs.
yeah.
No, I can't remember who makes their new units. A Chinese, but
I actually don't know. I keep guessing, but I don't know.
I
I haven't
can't
bothered.
remember. I have been told, but I mean, Damon quite likes it. I think he put one in not so long back. I mean, have you familiarised yourself with the new Grant? I've heard quite good things about it. I've not seen it myself yet.
We've got I have been down to Grant a couple of times now in Swindon, and played with their new unit. We are hoping to get one in the Ultimate showroom. One of our recent acquisitions, as I say, is the Navion heat pump that we have now in the showroom, and that looks very, very tidy, and the controls look very, very good. The one we've got in the showroom is a prototype, but the control is like a little tablet, and it gives you loads of parameters. Again, loads of parameters to look at and play with. So I think, unfortunately, we're not doing this control stuff ourselves, as you said, media in China. It's getting to. I mean, I'd love to have the money to go over there and knock on their door or bang their door down and say you need to get your control sorted out. Um, but because they are an OEM brand, we are going to have many, many, many of those heat pumps around the UK, which is a good thing. But they're all going to be running on that same controller, so it is difficult. I mean, going back to things that have changed in the last 20 years. I mean, flipping heck, heat pumps were hard pushed were pushed to get a sale with heat pumps. No one knew about the technology. You only had like the grand designs type properties, or maybe the couple that spent a lot of time in Europe and saw how the Europeans were doing things, and then came home and built their own house, and then they bought a heat pump from Europe, and as well as their house in a box and stuff like that. Um, to be fair, the industry hasn't wanted to change. The gas boiler. So to me, the gas boiler, the house builder, the gas boiler industry, house building industry, the utilities, the politicians, they all go down to the same pub on a Friday afternoon. And so, and they're trying to scratch each other's backs. So, I mean, look at that. Look at the house builders. I mean, was it 2035? I mean, it's absolutely ridiculous that we can't have heat pumps now. I was ready for it 15 years ago. Heat pumps were going to be going into every house, and we've still got people and house builders fitting one solar panel on a 5-bed house because it ticks a box.
Well, that's
Where's where? Yeah, where are the policy? Where are the regulations? Where are the real? people to make those changes to say, come on, guys, you are actually you're taking the mick here.
Well, it's
Um,
interesting. I mean, I've been chatting to quite a few people about this recently. So I believe, and so do some of the people I've been chatting to, think there's going to be a bit of a slowdown of heat pumps in the
yeah,
UK because, I did that article about the adoption curve, which was Rogers came up with this notion back in 1971, year I was born. No, we're still at innovator stage. So people having heat pumps into their home, we haven't even hit early,
targets,
what was it called? Early maturity.
numbers.
So so the bus scheme, yes, we've got the bus scheme, which is £7,500, but that doesn't help the majority of people. It's still a very expensive thing to have one of these in your homes. I know people that are constantly going and arguing about how people should have a heat pump, and yet they haven't got one in their own home yet, and they'll come up with all sorts of excuses. I can name a few people like that, always having a go at people that don't have them, and yet they haven't got one themselves. And they are expensive. They're very so. I think this year's been very good for the UK. The rest of Europe has slowed down, and that's bearing in mind the rest of Europe is also using air-to-air stuff. We're not. I mean, air-to-air stuff will start to become a little bit more popular.
Mm.
So we are going to see a slowdown. But whereas interestingly, social housing, local authorities, and developers I think are going to be the markets where we start to see a bit more of a. I don't think policy is always going to. I don't think policy is going to be the main driver for develop. I'm speaking developers at the moment who really want to put this technology in. Some of them did put the technology in 20 years ago, but unfortunately didn't have engineers like you. They had engineers put stuff in that didn't really know what they were doing. The stuff never worked properly. The developer got their fingers burned, and they haven't, understandably, they haven't bothered to sort of go near that technology again.
Yeah.
But they are astute enough to have now realised, okay, so it's not the technology that's at fault; it was how it got put in. That comes
Yes.
down to the engineer and the people designing the
Yeah.
system.
Yeah.
So they realise this. Obviously, their problem now is trying to find people that are competent to do that. But so I think that market is going to start to grow. Now, then you've got the problem is, well, where are we going to get all these? I mean, if we did have a policy said, right, tomorrow all new builds have to have heat pumps,
Mm.
most of them are going to get put in crap, Ken, as we know,
Yeah.
because
Yeah.
there
Yeah.
are
No, you're right.
the contractors out there, and the other problem. I was talking to one of the big manufacturers of heat pumps the other day who was involved in new builds. You'll get a developer that will contract that out, the heating side, and then whoever wins that main contract then contracts that out to
Yeah.
subbies
Yeah.
who
Yeah.
don't really know what they're doing.
Yeah.
And of course, you then end up with homes with poorly designed systems.
And then again, heat pumps are bad and they don't work, etc. I
Yeah,
mean, let me give you another angle on that. So go back to 20 years ago. If weather compensation was mandatory, if low temperature system design was mandatory, we'd now have a bank of good engineers that were already doing that,
yeah,
and houses that already had low temperature systems,
yeah.
and then their
So
transition from
customers would know that they didn't always have to
yeah,
have hot water in the rads, and
yeah,
we'd have an engineering force that understood that as well. And that's
yeah,
why the HHRC and BEMA have let us down dramatically.
yeah,
So I ignore most of their posting because yeah, this stuff got mandated in 2005 condenser boilers. If all the engineers have been sort of trained around that and start to put them systems in,
yeah.
we would have an adequate workforce to just transition over to heat pumps, just like that.
Yes.
So
And
they've
that
let us down.
customer would then, when they went from a gas boiler to a heat pump, all the extra upgrade stuff wouldn't have needed to be done because it was already low temperature.
Yeah.
So, which is what I've done in my own property. I made my system heat pump ready 22 years ago. Okay, I had a gas boiler. It was a very good Viessmann 200 gas boiler, weather compensated and everything else. But when I came to do the heat pump bit, it took me half a day. I was done.
Mm.
Boiler out, heat pump in, there I go. I
Mm.
had to do no changes to the rest of my system. It was already prepared and ready to have a heat pump.
That's a nice positive note, though, to end on, Ken. Well, thanks for coming on. You enjoy the rest of the Saturday because Ken and I have been doing this. It's Saturday morning, haven't we? So the
Yeah.
sun is shining. I might go on another walk now that the fun run's finished on the promenade that I walk on. Ken, thanks ever so much for coming on the show. Hope to speak to you again soon, buddy.
Yeah, it's been fun. Thanks, Nathan. Take care, buddy.
Cheers, buddy.